Hey, it's your tutor Courtney Waterman, lover of anime, manga, and math. And this is another session of Tutor Me Senpai. Welcome back, everyone. Today we're going to be jumping into a 10th grade topic, finding the intersection and the union of sets. More specifically, we're going to be talking about the differences between the union and the intersection of sets, as well as showing how we can show these things with a Venn diagram. Towards the end of our video, we're going to be using everything that we talked about in the first part and apply it to our question for today. So remember to stay tuned for all of that. If you have any questions about what we see today, well, remember you can put them in the comment box below. If you have questions about your own homework like see on this channel, remember you can visit me on Facebook at Tutor Me Senpai and tell me all about your homework there. When you find this video helpful, remember to leave the like, hit the notification bell, and smash the subscribe button so you know exactly when I drop my next videos. Well, without further ado, let's talk a little bit more about unions and intersections of sets. So as to not assume that everyone who sees this video has seen a set before, let's talk a little bit about sets first. So a set is usually denoted with some curly braces in such fashion, and it's really just a collection of items. So it could be numbers, so it could be like this. So just a collection of numbers. You can have a set be letters, so it could be words. It doesn't really matter what's in the set as long as it's a group of those items. So whether it be words, letters, or numbers, it doesn't really matter. A set is just a collection of those items. So take some real world applications of intersections and unions, and they apply for sets as well. So let's say you're on a street, right? So we have this busy street and it intersects another street. So this right here is called the intersection, right? We have one street going this way, right? And we have another street going this way. And where they meet is this intersection point, right? So just like in this street example, the intersection of sets is going to be where everything meets or where they have something in common. Now up here and down here, these are not in common with this part of this street and this part of this street, right? These are not in common. The only thing that they have in common is this section of street right here where they intersect. So when you think of intersections, it's fine to think of real world applications where two roads intersect, because that's going to give you an idea of how your sets are going to look. Remember, these are not in common. This is only for this road here, right? This is only for this road here. This is only for this road. This is only for this road. But this right here is what's in common for both of these roads. So this is where they intersect. Likewise, we have a similar example for unions. Let's say we have this real world example of 3 markers, right? These 3 markers are very independent. They're kind of just rolling around doing their own thing, not really tied to another. Although they bunch together, they can easily be separated and they're fine. Well, when we think of a union, we think of joining, right? So we have this, let's say we union it with this, we think of joining it. So now these two are together. So this one's by itself, it's rolling and doing its thing, but anywhere the red goes, this green one has to follow. Anywhere the green one goes, this red one has to follow. These are joined now. They're no longer just one unit. Same thing for this one. If we were to then union this, now we have none of them that are separate. They all are going to roll and go together in the same fashion. You can think of a union as joining everything together. And notice with a union, you're never going to just chop off different parts, right? It's all of you and all of you. Everything is accounted for. We don't have a topless red and kind of going in here and like, well, that's going to be our union. No. Everything is accounted for. Everything that makes you up, everything that makes you up, everything that makes you up goes into a union. You're joining things and you're becoming one bigger set. In this case, you're becoming one bigger group of markers instead of just being your solitary marker. So intersections look pretty much at what's in common, while unions look at everything that's in both or all your sets, because you can have more than one set being unioned. So what does this look like for actual sets? So let's say you have the set A is A, B, C, E, right? And the set B is E, F, G, M, right? Well, an intersection looks at what's in common. Remember your streets, right? What's in common? You don't really care about what's not in common. That's not in the intersection, right? The intersection only happens where they cross. So where do these cross? What do they have in common with each other? Do both sets have an A? No. How about a B? No. C? No. E? Yes. Both sets have an E. An F? No. And if you notice, we've already crossed out everything here, so nothing else in B is going to be in A. The only thing they have in common is this E. So we write it as such. A intersection, or intersects, B, and the result is the set E. Now, if we were trying to find the union, we write that as such. A union B, and what's the set that results from this? So the set that results from a union, once again, think of everything together. A, B, C, E, E, F, G, M. We want everything here. So all of A and all of B. So you have A, B, C, E. Now you might be tempted to write E twice. However, when you're dealing with sets, you only need to account for it once. If it's in the set, it's in the set. So instead of writing E twice, we're going to go to F, G, M. So intersection looks at only what's in common. Union looks at what's in everything. So if you look at this, this is all that's in A. This is everything that's in B. Everything in A and B are accounted for. Even though you only have one E, we're just looking at what's in everything. Now that we've talked about intersections and unions, there is a special case that occurs when there's nothing in common. So let's say we have the two sets, A and B, and A is 1, 2, 3, while B is 4, 5, 6. If we were to union these, that's going to be 1, 2, 3, 4, 5, 6. However, the intersection might not be as obvious. Our intersection would be whatever they have in common, but these don't have anything in common. So you wouldn't say 0 because 0 could be an element in one of them. So we don't have 0. Instead, we write an empty set, right? So you could just do this, but that's not the correct notation that we use. Instead, we don't write these brackets. Some people do, but you don't have to. And we do this symbol here. This is the symbol for an empty set. That means there's nothing in our set. This is the empty set, nothing here. So if you have two sets that do not have anything in common, and you try to find their intersection, that's simply going to be the empty set. Likewise, let's say we had C, which was the empty set. If you were to try to find the intersection between, let's say, A and C, well, if this is already empty, they don't have anything in common, right? So this is going to be another empty set. If you were to try to find the union of A and C, well, this is just going to be everything in A. Because if you union everything that you have in A with nothing, you're just going to get A back. So it'll look like 1, 2, 3. Likewise, B union C is going to be everything in B. So 4, 5, 6. So we have these empty sets. It's quite literally a set with nothing in it. So if we look at the notation between intersections and unions, remember we wrote something that looks like this. And I'm going to give you a little trick to try to help you remember which notation goes with what name. Now this is the intersection. And this is the union. Well, the first thing that jumps out to me would be this union here. Notice that the union, the U at least, looks like the sign for union, right? Whereas our intersection doesn't necessarily look like the I, so we can't do the same thing. But if you take this and you sound it out, this N, it sounds like N. And this looks like an N, right? So whereas the U looks like this sign, our N for intersection looks similar to this sign. So now that we've talked about what is an intersection and what is a union, we talked about the notation, let's talk about the Venn diagram. Now the Venn diagram is just going to be these circles here, right? And these circles are just representations of sets. So this is set A and this is going to be set B. And if we have, once again, A being, let's say A, B, and C, B being C, D, and E, then we would just write this set as A, B, C, C, D, E, right? That's your Venn diagram. Set A, set B. The set A contains A, B, and C. Set B contains C, D, and E. However, if you're trying to union these or intersect these, it looks a little different. The intersection of these two sets, let's say A intersect B, is just going to be C in this case, right? So how do you draw that? Well, that's just going to be the set C. This is going to be A intersect B. There's a different way you can write this as well. Instead of giving it its own set, you can use these two sets and merge them in this fashion. You have one circle here, and you have another circle here. This is for set B, this is for set A, and you have your A, B here, your D, E here, and what's in common with both would go in the middle, and that would be the C. This is another way you can write A intersect B. This shaded region right here is going to be A intersect B. You see this, it's just that. And if you're trying to find A union B, let's say we want to shade that. So I borrow this green one here. A union B. Well, that's going to be everything in A, everything in B, and also what they have in common, right? So you notice we're pretty much coloring everything because a union takes everything into account. A union B is going to be everything here. So if you write it out, it'll be A, B, C, D, E, everything. So this is how we can show our sets and our unions and intersections using Venn diagrams. You don't have to write them in their own set. You can pretty much combine our sets in this fashion and then shade what you need. So now that we talked about intersections, unions, and even the Venn diagram representation, let's look at our question for today. So we have two sets, A being, B being, and we want to find A union B and A intersect B. I'm going to take it a step further and ask us to pretty much draw those out in Venn diagram form as well. A union B, let's start with that. Well, that's going to be everything in A and B. So if we put our curly braces here, let's see what's in A. 1, 2, 3, 4, 5, 6. Correct? All right. What's in B? 2. Well, do we already have a 2? Yes. So we don't write it twice. 4. Well, do we have a 4? Yes. So we don't write that twice either. 6. Do we have a 6? Yes. So we don't write that twice either. 8. Do we have an 8? No. So we're going to make sure we account for that 8. How about 10? Nope. So we're going to make sure we account for that as well. Now we have everything that's in A and B. 1, 2, 3, 4, 5, 6 is in A. 2, 4, 6, 8, 10 is in B. If we were to look at this, this would be A, B, C, or D. Well, this looks like it's going to be answer B, right? 1, 2, 3, 4, 5, 6, 8, 10. Now, once again, don't fall into the trap of C and write things out twice. If it's in a set already, we are not going to write it multiple times. C is the wrong answer. We only write it once, even if it shows up in multiple sets. We only write it once. All right, how about A intersect B? Well, that's going to be what they have in common. Do they have a 1 in common? No, so we don't write it. How about a 2? Yes, so we do write that one. Do we have a 3 in common? No. How about 4? Yes. 5 in common? No. 6? Yes. And 8 and 10? No, we don't have any of those in A. So the intersection is going to be 2, 4, 6. And which one does that correspond with? That corresponds with A. Answer A. So these are our two answers. Let's look at how they look with graphs. So we're going to graph this with our Venn diagram, and we're going to have two circles, right? And this is going to be A, this is going to be B. And what's going to be in all of these? Well, we have 1, 2, 3, 4, 5, 6, 8, 10. 1, 2, 3, 4, 5, 6, 8, 10. And this is a 6. And if we were to highlight this to show what our A union B, we would just highlight everything. Because we want everything that's in both. The shaded region is going to be A union B. How about this intersection? Well, we're going to write the same thing. So it's going to be 1, 3, 5, 2, 4, 6, 8, 10. This is A, this is B, and the shaded region is going to be this intersection here. So this is going to be A intersect B. Well, I hope you're able to follow with today's example. Remember, if you have any questions at all, if anything confused you, put it in the comment box below. I would love to be able to help you as much as I can. Remember, if you have any questions about your own homework you'd like to see on this channel, you can always visit me on Facebook at Tutor Sempai and tell me all about it there. If you haven't done it already, remember to hit that like button, demolish that notification bell, smash the subscribe button, and share with a friend who could also use the help. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this is another session of Tutor Me Senpai.